Saturn V Quarterly Film Report number 14 covers progress during the period March, April, and May 1966. Inside the 48 stories tall vertical assembly building at Launch Complex 39 of the Kennedy Space Center, a mammoth and historic undertaking, assembly of the first complete Saturn V space vehicle, began on March 15th, with erection of the vehicle's first stage on a mobile launcher, from which future Saturn V's will be fired. The initial vehicle will be used in checking out launch facilities and ground support equipment at the launch complex. The first stage was built by the Boeing Company at Marshall's Michoud Assembly Facility in New Orleans. On March 25th, the next phase of the complex assembly operation was accomplished, with the second stage of the facility's checkout vehicle moved into place, hoisted by crane above the first stage, and mated to it. This stage was built by the Space and Information Systems Division of North American Aviation at Seal Beach, California. Erection and mating of the third stage was performed on March 29th. The Douglas Aircraft Company produced the facility's checkout stage at its Huntington Beach facility in California. The facility's checkout instrument unit, manufactured by International Business Machines at its facility in Huntsville, Alabama, was joined to the third stage on March 30th. During April, NASA and contractor engineers and technicians were busy installing various dummy ordnance items, such as ullage and retro rockets, and checking out GSE inside the vertical assembly building. And on May 2nd, mating of the facility's checkout Apollo spacecraft, built by North American's S&ID, marked completion of assembly of the first Saturn V vehicle. On May 25th, the vehicle, standing 350 feet tall, was rolled out of the VAB to begin its maiden journey, requiring 6 hours, aboard the mobile launcher to Pad 39A, 3 miles away. Test objectives for the facility's checkout vehicle include evaluation of launch vehicle assembly and handling operations, evaluation of propellant and pneumatic servicing operations, evaluation of compatibility of launch vehicle with GSE and facilities, determination of vehicle response to ground wind conditions, and training of personnel to process Saturn V launch vehicles. Manufacturing and checkout of first stages by the Boeing Company and the Marshall Center continued throughout the quarter. In first stage ground test operations, the upper assembly of the structural test stage, comprising the intertank, LOX tank, and forward skirt, was installed in Marshall's load test tower in mid-April and prepared for structural tests due to start next quarter. Similar testing was successfully completed this quarter on the stage's lower assembly, comprising the thrust structure, fuel tank, and intertank. The first flight stage, which was successfully static fired at Marshall last quarter, underwent refurbishment and began post-static checkout during the report period. The stage will be shipped to the Kennedy Space Center in August. The second flight stage was installed in Marshall's static test stand on May 17th, following completion of post-manufacturing checkout. A single acceptance static firing of 125 seconds duration is scheduled for the stage on June 7th. At Marshall's Michoud Assembly Facility in New Orleans, assembly of the third flight stage was completed on March 9th, and the stage was moved into the stage test building for post-manufacturing checkout. This is the first flight stage assembled by Boeing at Michoud. 2 ground test stages had previously been assembled there. After completion of checkout, the third flight stage will go to the Marshall Center for acceptance static firing. Vertical assembly of the fourth flight stage has been completed at Michoud. This stage will be the first flight booster destined for acceptance static firing at Marshall's Mississippi test facility early in 1967. A new upper fuel tank bulkhead for the fifth flight stage has been welded into position to replace one which partially collapsed while being drained after hydrostatic testing on April 28th. The collapse was caused by a negative internal pressure due to an improper test procedure. no impact on the assembly schedule is foreseen. Structural assembly of major components for the 6th flight stage is now in progress by Boeing-Michoud. Fabrication of components such as bulkhead gore segments for the 7th flight stage is also underway. The first static firing test of the 2nd stage flight weight all systems stage was successfully held on April 23rd at the Marshall Center's Mississippi Test Facility. Running 15 seconds as scheduled, the test marked the first operational use of MTF, NASA's newest facility. The first full duration, 355-second static firing of the stage was successfully conducted on May 20th. Gimbaling of all 4 outboard J-2 engines was performed. The full duration test had been preceded by a 150-second firing on May 17th, following 3 earlier attempts. In a second scheduled full duration firing on May 25th, a fire developed around the number 4 engine recirculation valve, burning until fuel was detanked using the emergency dump system. On May 28th, an explosion of the stage's liquid hydrogen tank occurred due to overpressure during a leak check test, and the stage was almost completely destroyed. Pressurization was with helium, and no liquid hydrogen was involved in the blow-up. The tank was overpressured as a result of the tank pressure switches being disconnected and subsequent ground override of the stage and facility vent valves to obtain pressure during the leak check. Facility damage appears to be repairable prior to scheduled arrival of the first S-2 flight stage at MTF next quarter. Possible program impact due to the accident is under investigation. The thrust structure assembly for the 2nd stage high force test program was shipped in April from S&ID's Seal Beach facility to the Wiley Laboratories in Huntsville, Alabama, where acoustical and mechanical vibration testing will get underway next quarter. At North American's Santa Susana, California Field Laboratory, 2 full duration firings of the 2nd stage battleship stage using flight configuration J-2 engines were held in March to complete the major test program of battleship development. The battleship stage will be maintained in a minimum capability status to allow additional firings if needed. Work on 2nd stage flight stages continued at Seal Beach, with systems installation for the first flight stage completed in April. Systems checkout, now in progress, will be finished June 30th, and the stage will then be shipped to MTF for acceptance static firing. Pneumostatic testing and cleaning of the 2nd flight stage have been accomplished, following completion of vertical assembly in April. Systems installation, now underway, is expected to be done by July. Assembly of major structural components for the 3rd flight stage is complete, and the stage is in vertical buildup. For flight stages 4 through 6, fabrication and subassembly of structural components are in progress. The first flight stage was shipped by ocean-going barge on March 11th from Douglas Aircraft Company's Huntington Beach, California facility and arrived 4 days later at Douglas's Sacramento Test Center for acceptance firing. On March 21st, the stage was installed in SACTO's Beta Test Stand Number 1. Pre-firing checkout began 9 days later, and a fully successful acceptance static firing test of 455 seconds duration was run on May 26th. In the test, the stage demonstrated the J-2 engine restart capability after a simulated orbital coast period. The stage initially fired for 150 seconds, then after restart for 305 seconds. Delivery of the first flight stage to KSC is scheduled for July. Factory checkout of the 2nd flight stage was completed May 9th at Huntington Beach. The stage is being prepared for shipment to SACTO on May 31st aboard the Super Guppy aircraft for acceptance firing scheduled in late July. Because of the requirement for assembly of a new hydrostatic test stage, occasioned by damage to the 3rd flight stage's LOX tank during hydrostatic testing last quarter, certain flight stage structural components are being interchanged to provide minimum overall schedule impact. The damaged LOX tank has been repaired and successfully retested and will be part of the new hydrostatic test stage. Structural fabrication is continuing on components for the 4th and 5th flight stages. The S-4B stage simulator was removed from the vehicle checkout tower at Saturno in March, following completion of factory checkout, and was shipped by Super Guppy to the Marshall Center for use in its Saturn V systems development facility. The stage simulator consists of a thrust structure and functional mock-up engine, plus forward and aft skirts. Acceptance test firings of the auxiliary propulsion system modules for the first flight stage were held on May 6th and 13th at Saturno's Gamma Complex. All 5 F-1 engines for the 4th S-1C flight stage, plus 3 of the engines for the 5th flight stage, were delivered by Rocketdyne during this quarter. Rocketdyne's newly completed vertical assembly production line at the Canoga Park, California plant is now in operation and producing F-1 engines at the rate of 2 a month. Engines delivered this quarter were of the Qual-2 configuration, qualified for manned flight reliability and designed to meet the additional payload requirements of the 4th Saturn V and subsequent vehicles. An intensive F-1 engine component qualification test program was continued by Rocketdyne throughout the report period. This static load test of the hypergol manifold assembly, performed at 0 degrees Fahrenheit, simulates effects of engine storage at low temperature conditions. In vibration testing of the flight instrument junction box, stroboscopic photography transforms the action into slow motion for engineering analysis. A total of 12 J-2 engines was delivered by Rocketdyne this quarter, including the first of the new uprated 230,000 pounds thrust engines, which went to the Marshall Center for Static Firing Tests. The engine has 5,000 pounds more thrust than previous J-2s. Rocketdyne's new J-2 engine production line at the Canoga Park plant features positioning of engines at floor level to allow ready access by personnel. Also, each engine can be rotated to the exact area desired. A teardown engineering inspection was held in March on the J-2 engine, which had previously completed the qualification test series at Santa Susana. All components were found to be in excellent condition and suitable for use after reassembly in either the spares support program or the research and development program. At the Air Force's Arnold Engineering Development Center at Tullahoma, Tennessee, the Douglas S-4B battleship stage to be used for tankage in a series of J-2 engine environmental verification tests was installed in a test cell, and the engine was mounted. Firing tests are scheduled next quarter for verification of start, restart, and performance at simulated high-altitude conditions. The Flight Systems Instrument Unit, assembled at MSFC, was delivered in early March to Douglas Aircraft's Huntington Beach facility, where preparations were made for functional tests scheduled for late May in an environmental chamber, simulating orbital thermal vacuum conditions. During the vacuum environment test, the IU will be mated with a third-stage forward stage simulator and a lunar module thermal simulator. Vibration testing of the second vibration test IU was successfully conducted at Wiley Labs' Huntsville facility during April to verify the flightworthiness of the IBM-produced unit for Saturn V vehicles with respect to specified vibration environments. A third structural test IU is now being built by IBM Huntsville, scheduled for delivery to MSFC in June. Investigation of the crumpling of the second structural test IU last quarter during load testing over the ST-124 stabilized platform position indicated need for continuation of tests using a new IU. Component installation for the first Saturn V flight IU has been finished at IBM, and checkout is in progress. Upon completion, scheduled July 19th, the IU will be shipped to KSC. Structural fabrication of the second Saturn V flight IU, which began March 21st, is nearing completion. Component installation is due to be finished in August. Buildup of Marshall's Saturn V Systems Development Facility neared completion this quarter, with installation of the third stage forward section with breadboard instrument unit attached, plus the third stage aft section and J2 engine. The facility is a breadboard or simulation of Launch Vehicle Automatic Checkout GSE at Launch Complex 39 KSC, plus components simulating a completely assembled Saturn V vehicle. Installation and checkout of equipment around the interior circumference of the breadboard instrument unit is well underway. Installation of electrical support equipment is now complete in the breadboard areas, simulating the LC-39 Launch Control Center and Mobile Launch Facility. Ground equipment tests at the breadboard LCC were finished this quarter, as well as debugging of the checkout tapes for use at KSC in checkout of the Saturn V facility's checkout vehicle. At the Marshall Center's Saturn V Dynamic Test Stand, the shakers which will vibrate the Saturn V Dynamic Test Vehicle during dynamic testing this fall underwent acceptance testing during the quarter. The shakers, built by Ling Electronics, Anaheim, California, were tested against a 47,000-pound mass of steel mounted on wheels on a track. 3 such shakers will be installed in the Dynamic Test Stand, 1 for lateral mode and 2 for roll mode. The S2 facility's checkout stage will be shipped from KSC to Marshall in September for use as part of the dynamic test vehicle as a result of a decision in early May instead of using the all-systems stage as originally planned. At Marshall's Mississippi Test Facility, construction continued on second stage static test stand number 2, designated A1, while the first or A2 stand became operational with the initial second stage all-systems stage firing. A1 superstructure steelwork was topped off in April, and installation of siding was begun. At MTF's dual-position first stage static test stand, the B2 position is rapidly nearing completion. Fabrication of the booster support frame is underway, and sheet work on the engine removal platform has been finished. At the B1 position, installation of load frames for the flame deflector is in progress. Structural steel and engine removal platform steel is being received on site. Despite the setback incurred due to the S2 all-systems stage explosion, March, April, and May witnessed the achievement of a number of vital program goals, including virtual completion of the Saturn V Systems Development Facility, preparation for environmental testing of the Flight Systems IU, preparation for simulated high-altitude tests of the J2 engine, successful acceptance testing of the first third stage flight stage, initial static firing of the second stage all-systems stage, marking first operational use of MTF, and culminating in the major achievement of assembling for the first time a complete Saturn V vehicle at KSC for checkout of facilities which will be used in launching the Saturn V flight vehicles to come.